Yes, good morning, students. Welcome back to this MPMC class. So today's session we are going to start with the addressing modes. So actually, what is addressing modes? Before going into this topic, you need to know or we get take a short glance of what we have covered in the last classes. So I started with the syllabus flow. So in the syllabus flow itself, it is mentioned it starts with 8086 processor, whereas in the regulation 2013 it starts with 8085 processor, which is an 8-bit processor, but you are studying a 16-bit processor. So whenever the question is asked, you should remember it is a 16-bit processor. That is 8086 is a 16-bit processor. Okay, so in order to know how the processor works, so processor is nothing but which process on the certain data and produces the output. So in terms of producing the output, we can refer like in terms of what are the references you can go with processor, DSP processor, okay, digital signal processor. So I gave a livelihood examples where these processors are used, right? So here in microprocessor, why this name microprocessor arrived means micro is nothing but which is decimated from the word 10 power 6. So it could they perform on data which is having up to 10 power 6 of this bit rate, that is data rate, right? So more number of data can be it is nothing but we can process on such certain data. So bit by bit, that type of processors enables the input signals and produces the output, right? So next, coming to the point where we have studied about the instruction set. So, as a programmer, before as a CSE students, you are willing to become a software engineer. That is a programmer. So, what is your role play? You should know how they program executes, right? So, for that you will write the algorithms, right? So, what is the variables you need? What is the operations you are going to perform on it, and you will give as such, right? So, this is the way you work, right? So, when comparing like this, okay. Okay, okay. To introduce you the concept of addressing modes, and I want to tell about the type of addressing modes, right? And addressing modes, each one will be explained with an example that is based on the instructions and summary. That is always I used to go with the summary points where what you understood from today's class, and I'll give the what will be our next topic, and I'll post an MCQ. So this is how I have planned. So going into the possible questions on this today's topic. So it is a very important topic as far as the Anna University is considered. So there are variety of questions. You could see the same type of question which is asked in a different way. I think you could see here the addressing modes is a title where it could be asked in a different way. Only the words are jumbled, but the answer is nothing but which you should write about the addressing modes. So, for example, the first question which is asked in one question paper is with an example, explain the addressing modes of 8086. It means you have to explain the each addressing modes. The addressing modes will be similar to that of the instruction sets, instruction classifications. So here also we will classify the addressing modes, and that each one should be explained with an example. So when we are when I took the class on instruction sets, you could see how I have taken. So one instruction will be explained with an example. So if there is an instruction called move, right? So we want to move the content, that is data transfer instruction, move the content from source to destination. So for example, if it is a 8-bit transformation of data or transferring of data, it is nothing but move AL comma BL. So the content of BL will be moved to AL. That is the example I have given. So likewise, you have to pick out the examples for each of the addressing modes and you should write. So when you will be very clear at the end of this class how you could write these questions. So list out the different addressing modes of 8086 and explain them in detail with one example for each. The same question, right, which is asked in a different way. Next question you see, it is like list the various addressing modes of 8086 microprocessor with one example. and explain the addressing modes of 8086 in detail. Give an example for each mode. What is the addressing mode of the following? So given an instruction, sometimes they will be asking you what is the instruction set, or what is the addressing modes of this following instruction. So this can be asked in 2 marks. If one instruction is asked, means it is asked in 2 marks. If it is above, that is there are more instructions given, means it could be classified under 4 marks. Are you clear? Are you clear?
Yes, ma'am.
Yes, ma'am. Okay, coming to the introduction part, the agenda, the introduction part of addressing modes. Let me explain what is addressing modes. So, what is addressing is nothing but it is the way or manner in which the operand is given in an instruction. So, you must know what is meant by operand. Are you all clear what do you mean by operand in an instruction? Any doubt? Yes? Anybody know what is operand? Can explain now. So I'll give the example now. Then you can imagine from the instruction set what we have explained. Then you can give the answer, right? So operand is nothing but the number or data which you wish to perform certain operations. Okay, that is called as an operand. So it is the value to be operated or data to be operated. Okay, clear? Value to be operated. So now for an example, if I am taking the instruction add ax comma cx. So in this instruction, what is called the operand? Ax comma cx is called as the operand. Are you clear? So operand is nothing but this is the instruction. Add. I am telling you, take that note. Okay, take that note is the instruction. You should take the note. So here also add ax comma cx is the instruction. So you should add the variables with ax and cx. So take the notice, that is an action, right? So after that particular note here is the operand. So here what is here? Ax comma cx will be your operand. That is the data to be operated. Are you clear? Can you give any other examples for this operand? Anyone? Okay, let me write one instruction so that you will be able to give the instructions or examples. Shall I? Okay, from this instruction, okay, MOV, okay, MOV, same, BL, comma, CL. Can you tell me what is the operand from this instruction or operand in this instruction?
BL and CL.
Yes, BL comma CL is the operand. Are you clear now? Very good. So it is the data to be operated, right? So all instructions that access the data uses one or more addressing modes. So you could see here, this is the operand, and addressing mode will tell in a particular instruction how this operand are to be operated. Based on the operations on this operand, this addressing mode is the one which tells the instructions. That is, it's a way or manner in which the operand is given in an instruction. So it could be from source to destination or destination to source, etc. It differs based on the instructions that we have already studied. So we'll see a deep insight into the instructions, that is addressing modes one by one. Okay. All instructions that access the data use one or more addressing modes. So not only one addressing mode, some instructions might have only one addressing modes, whereas some instructions might have more addressing modes. Clear? So now we will see how these addressing modes are further classified. So the memory address of an operand consists of two components. What are the two components? We'll see. Already we have seen this, that is the physical address. I have clearly explained what is this physical address mean in the very introduction, very first class or second class, I think. So how you should calculate in the architecture part, that is in the arithmetic logic unit, which is happening in the BIU, whereas in the execution unit, what happens, right? So what is the need for that physical address? So calculation of a 20-bit address, that is called as a physical address. So we'll see how this physical address of any instruction in the memory is happening. So we'll see that. So I'll write it here. considering the physical address, right? So it has two components. So what are those two components? Let me write it here. So it is a segment address. It's called as the segment address. So what is segment address? I will explain. And next one is your offset address. Next one is your offset address. So these are the two components which is present in the physical address. So let me explain what is this segment address. So what is a segment address which consists? That is, it contains the starting address of the segments. So segment address consists of the starting address. So we know there is a stack of addresses where the instructions are, data will be stored. It consists of the starting of the segment, okay, in a memory. So all those things are constituted in the memory. So the segment address consists of the starting address of the segment in a memory. Now coming to the offset address, it plays a major role in this instructions, that is in physical address classification. Okay. So let me explain this. What does this physical address carries? So it is the address which is having three elements. Again, this is having three elements within a segment, or it is nothing but it is having the address within a segment which is classified into three types. So what are those three types? We'll see it one by one. So first one is your displacement. Okay, and second one is your base, and third one is your index. Okay, so what does this displacement does? Displacement is nothing but a 8-bit or a 16-bit immediate value. Okay, what is mean by this base? All the, that is, we can say all the contents of this, we have seen in base, that is architecture, base registers. Okay, so all the contents of base register constitutes this, all the contents of base register. So what is the base register? We know it is BR, which is specified as BP or BS, base segment, right? So now coming to the index part. So what is the index part? So index is nothing but it consists of, this is BX. Index consists of all the contents. So here also it is specifying the index register, okay, all the contents of the index register. So what is the index register? So specified with SI, source index, destination index, source index and destination index. Are you clear with this concept?
Yes,
Are you
ma'am.
clear with this concept? So here, this is the concept we are studying it, right? So now we will see how this constitutes once again. Okay, so this base is very important, which constitutes only with the base register. So when an instruction carries with respect to the base registers, you could see the offset address placing with the base registers. Sometimes it will be with the respect to the index registers. So index registers now, and that is whatever you have explained with respect to the index register, all constitutes with this index register. So all these constitutes. So the offset address will be the combination of these displacement or base or index registers only. Are you clear? Yes. Are you clear? So what is this offset address? Is a combination. It will be either with the respect to the displacement, base or the index register. So it is the other name for this offset address is called as the effective address. So simply in a question paper, if they are asking, if your EA is this much, you must calculate the value of the physical address in data. They are asking, you should be able to write what will be the physical address of it based on the starting address. Are you clear? So you must know the starting address where the instruction carries, and you must know the offset address. Based on that instruction, what is given, we can calculate the 20-bit physical address. Are you clear? Shall I go with the next?
Yes, ma'am.
Yes, ma'am.
Yes. Okay, Gana. So coming to the introduction, that is actually the introduction part, which is classification. So how we could remember this addressing modes? Yeah, it is sometimes typical with respect to the addressing modes. How we can remember or recall such instruction is very, very tedious. So when you are studying it for the first time, you get confused. Don't panic about it. So just remember, as a programmer, so if you want to become a software engineer, you must know how these addressing modes are done. Okay. So in order to know where this data are stored in a physical address. So now as I have mentioned, now we are talking about the virtual address. So we know if I want to save any data, if I want to save the file, what I have done as a PPT in the drive location of F drive in my laptop. So that is the physical address. So I know this content of my PPT is stored in the particular F drive. Okay, this is for my purpose or for the usage or understanding purpose of the man. Okay, for human. So whereas the machines, how does the machine understands is different. So why you want to study this addressing mode is a big question. So you must study the addressing mode. When you become a programmer, you must know where is that specified addressing fetched. So you must know the exact location of the address to which the data is to be delivered. So then only you will write and execute a program which will be a successful one. Are you clear? So this is the starting point. So this don't confuse. It is a very easy one if you understand the concepts. And you could see this, you could relate this with the subject which you will be studying in future or in anything that is in terms of computer organization. That is advanced computer organization or computer organization and architecture, CAO. Okay, so those subjects, the basic is this one, the pipelining architecture, whatever the architecture, explaining of this instruction classification, how the data is fetched from one place to another, all these the data structures, so the advancement of these CAO, right? So all these DBMS, everything you should have the basic knowledge. So now you are studying only the basic knowledge. Okay, please remember it. So now coming to the addressing mode of 8086, which is classified based on two types. So one is for the branch, right? And another is for the data. One is for the branch and another is for the data. Okay, so how you will remember it? So whatever it is, I want to write only in point of exam point of view. So there is some keywords. So based on the keywords, you can recollect the addressing modes connected with the instruction. So remember the keywords, whatever they are being used. So hint here to remember this addressing mode ECD is to remember the keyword. So keyword, how you can analyze the keyword, that also I will explain one by one. So first you should know the types of addressing modes. So there are some 11 addressing modes given. Okay, so 11 addressing modes are specified. So here you are particularly studying only for this 8086 microprocessor. So you should remember the addressing modes will be present for every processor. Okay, this addressing modes and instructions will be specified for every processor. Pentium 4, Celeron, whatever it is, everything has the different addressing modes. There are huge number of addressing modes present based on the type of processors we are used. So for your syllabus, since we are concentrating with the 8086 microprocessor, we are studying with the 8086 microprocessor addressing modes alone. Are you clear? So there are only 11 addressing modes corresponding to this 8086. A short comparison with 8085, which is an 8-bit processor, which constitutes only the 5 types of addressing modes. Simple, very basic. Five addressing modes are present, whereas here there are 11 addressing modes. So when you go for more number of bits, the complications are there, but yet it is very much useful when you go for the programming concepts. So why I am taking this much effort or taking much time on this addressing modes and instruction set is because this is the base for your laboratory also. So I will not again take the programs or whatever it is. So in the syllabus of first unit itself, we'll go through all the programs. So if I want to give the instruction, add this 16-bit numbers, you should be able to write a program which adds these two 8-bit numbers or 16-bit numbers, whatever it is I'm instructing. So you should be capable of that. That's why each bit of instruction is explained clear. Are you clear? Easy, and it is so. Among these instructions, which one is a very easy addressing mode? Here is, any idea? Very easy addressing mode will be your immediate addressing mode. Okay, I will give the very easy addressing mode will be your immediate addressing mode, or sometimes with the direct addressing mode and register addressing mode. So which will directly gives this is to be done. Whereas in terms of remaining of the addressing modes, there will be some indirect way how the physical address is to be identified and it is executed. Are you clear? Yes. Coming to the immediate addressing. So we will start with the immediate addressing mode. Are you clear with that introduction part?
Yes, ma'am.
Yes. Coming to the immediate addressing mode. So what is immediate addressing mode? Here is the data or the operand. So always operand is nothing but, remember, it is the data. Okay. If they are mentioning in a program about the operand, it is nothing but the data. Don't get confused. Okay. The data or the operand is specified within the instruction itself. So immediately, the keyword here is the immediate. Okay. So in 8085 and all, there is an instruction called MVI C,00H. What does this instruction does is, it directly moves the content of 00 into the C register. Okay, so this is the instruction which directly, so I stands for immediate, MV stands for the move instruction. Whereas here there will be a little bit of understanding to know what is the immediate addressing mode with respect to the instructions. Now coming to this, MOVCH comma PH is the example given for the immediate addressing mode. What does this instruction does? Anyone, can you explain what does this instruct? I will explain one. Okay, second example, somebody can explain. Let me take. Yeah. Okay, so what does this instruction does here is, always I said this will be your destination and this will be your source. So remember, always in microprocessor, the data whatever is specified is moved from source to destination. Okay, source to destination in the left hand direction, always specified in the left direction. So what is here? The source is 35. So what does this does? The content 35 is moved to the CH. Are you clear? Are you clear now? So the content, okay, which is specified in C, 35 is the source, which is moved to the destination. What is the register specified? It is CH. If I want to move a particular data into a register, we can go for this type of instructions. So here this is the example. So the content is immediately transferred into CH. So here this is a 8-bit data, right? CH. CHங்கிறது என்னது? CXல இருக்கிற ரெஜிஸ்டர்ல CHCL, which specifies up to an 8-bit and next 8-bit. So the content of 35 will be considered like this: 0, 0, 1, 1. This again 0, 1, 0, 1. This is the 8-bit data which is moved to CH. The machine understand like this. Are you clear?
Yes, ma'am.
What happens with move dx, comma B120H? So what is this? X specifies?
16-bit.
Yes, very good. So in the register column, we have AX, BX, CX, DX. So DX specifies a 16-bit. So you here also you could see the difference between this and this. This is an 8-bit, this is a 16-bit. So 20. So 20 and B1. So B120, the content B120 is moved to DX immediately. Yes. So if you see any of the data in the source, you can say it is an immediate addressing. Are you clear?
Yes,
It
ma'am.
can be 8-bit or 16-bit. Yes, I'll move to the next. Next is the direct addressing mode. So what happens with the direct addressing mode? We'll see. Okay. Are you understanding till this? Yes or no?
Yes, ma'am.
Yes, once again, with the direct addressing mode, I'll go with more examples for your better understanding. Okay, yes. Okay, coming to the direct addressing mode, how this direct addressing takes place. So here one of the operands is a memory location given by the constant offset. So we know the physical address, it is a 20-bit address which is created with respect to the index registers, whatever is given, right? So with respect to the offset as well as the segment register. So here the 16-bit effective address is taken directly from the displacement field of the instruction. So out of the 20-bit, 16-bit effective address is taken directly from the displacement field of the instruction. Remember this point. And this EA, the effective address or the displacement taken from the displacement field, will be the distance of the memory location from the current value of the data segment. So if this is the segments register which is here, okay, so it's the starting address is 2000H. So it goes on incrementing like it 2001, 2002, 2003, 2004, etc. Okay. So here what they are telling here is the EA or displacement is the distance of the memory location from the current value of the. So if the data segment is in this 2000 location, okay, DS is specified in 2000 location. What happens to EA? The memory location will be shifting to some other numbers from respect to the DS. So specified from the specified DS, it will be shifted to some other location. What is that shift? So here the BIU, that is bus interface unit, will shift the DS. Okay, this is the DS 4 times to left and adds EA to generate a 20-bit address. We will see the example how it is happening. So for example here the given instruction will be in terms of move, this is the address location specified, okay, where AX is given. So the content of AX will be moved to this register. So here this is the memory address or memory location, we can say destination in terms of memory location. Here the AX is nothing but the registers we are specifying it. Are you clear? Are you clear? So with respect to the explanation, let me take an example. If EA, I am specifying the effective address. So with respect to this, if I am specifying EA as some value of 0040 with respect to 16-bit. So this is a 16-bit address location. And what is our data segment here is 3050 16-bit. So this is nothing but the memory location which specifies the address. That is why it is specified in terms of base 16. Are you clear? Yes. So what happens here when the instruction is carried? Let me explain the box. So here, okay. So imagine this is the stack. From that stack, I am taking an EA content, which is a 16-bit. We want to generate a 20-bit physical address. So are you clear with the 16-bit? So this is the 16-bit. How this I am telling it as 16-bit means, for example, for 3050, I will write how this is specified as a 16-bit. Yes. If 3050, when written in a, so what is the value of 3 in hexadecimal? It is 0011. For 0, it is 4 zeros. For 5, it is 0101. For again, it is 4 zeros. So each of this bit is a 4 bit. So 4 plus 4 plus 4. You could see here 4, 4, 4. So 4 fours are 16. So this is a 16-bit location. We want to generate a 20-bit. For this 20-bit generation of physical address only, we go for this displacement of this DS 4 times to the left, and it is added with the 20, that is the 16, that is added with the DS to get the final physical address. So let me consider here, if the EA is specified as 040, so I am specifying EA here, okay, and I am specifying DS here. So what is my DS? It is 3050. 3050. So actual data, whatever it's given. So what happens with this EA here is it gets shifted to 4 times. So 4 times, if it is shifting, means with respect to rotate operation only it happens. So you can just write it is shifting 4 times. So 4 times shift means each of that bit will be shifted 4 times. So it comes like this 0040. Okay, so you know the rotate operation, right? If it is shifting 040 with respect to 4 times, so again this 00 will be 000, which is shifted 4 times means again it will come to the position, same position towards left. So we are getting the same value of 0040 here, which is added. So here what happens? We are going to add this and give the final physical address location. So what it will be? It is 0. 0 plus 4, it will be 4. 5, 0, 3. So where it will be stored means, example, if I am taking it as 3050, so again it goes for 30540 location only, the physical address. So what happens? Hence the content of AX, whatever is specified, will be moved to this physical address. Are you clear? That is why the direct addressing mode is little bit tedious. Are you clear now? Are you clear now? So we have generated a 20-bit physical address. Shall I move?
மேம் இன்னொரு எக்ஸாம்பிள் வச்சு சொல்லுங்க.
ஓகே, ஸோ இப்போ எக்ஸாம்பிள் வந்து இதே எடுத்துக்கலாம். ஓகே, 5678 எடுத்துக்கலாமா? ஸோ ஒரு 5678ங்கிறது ஒரு லொகேஷன் வச்சுக்கலாம். இதுதான் வந்து டிஎஸ். ஸோ டிஎஸ் ஹியர் இஸ் 5678. ஓகே, ஸோ ஐ வாண்ட் ஏஎக்ஸ். ஸோ இஃப் ஏஎக்ஸ் கண்டென்ட், இதில் வந்து உங்களுக்கு கண்டென்ட் எப்படி மூவ் ஆகுதுங்கிறது பார்க்குறது முக்கியம் இல்லை. இஃப் ஃபிசிக்கல் அட்ரஸ் கண்டுபிடிச்சிட்டிங்கன்னா ஏஎக்ஸ் கொண்டு போய் அந்த இடத்துல சேர்த்துரும். தட்ஸ் த கான்செப்ட். Very clear? So the concept here is we want to generate, we can't move directly to this memory location. We have to generate a 20-bit physical address, and then the particular address location, that is whatever the register location is, will be moved to that particular location. So if EA, so for this type of instruction, they will specify what is EA, what is DS. Are you clear? So if I am specifying this as DS, let my EA becomes some 1008. Okay, so what happens here is, so it gets shifted with 1008 times. You just shift it. You want to actually replace it from this place location, whereas for EA content it shifts to left. So here, after shifting operation, the content will be remaining the same, because it is a 4-bit content which is moved again. So you need not worry about it. Just move the content and add it. So what is it? It is 8 again, 7 with 7, 5. So the final physical address will be not this 5678, it will be moved to, the AX content will be moved to 57788. Are you clear now?
Yes, ma'am.
Yes. Okay. Okay, now coming to the register addressing mode. So what is the register addressing mode here is the instruction specifies the register containing in the data or the operand. So register, you could see here the registers are used in the register addressing mode. The hint here is the registers. So here the source and destination operands will be registered. So if they are specifying directly with some registers, so there is no data. Okay, the data will be given. So in the previous example also, the data is not given. AX is not given. So AX will be finally you will be inputting the data after the load, after you load the program. So in such a way you can load this content and you can move the content, right? So here also you can move or XOR or subtract or whatever you could do, you could perform with the register addressing. So you could see here, for example, subtract bx comma ax. So what does it does? So the content of bx is subtracted with respect to ax. Are you clear? So here you could see here the registers are only specified. Yes, very simple. It's very simple and it is easy to understand. The terminology where you will be suffering or you will be finding difficulties like this type of direct addressing modes. Okay. Shall I move on?
Yes, ma'am.
Yes. Next is the register indirect addressing mode. So what does this register indirect addressing mode does? So here also we should go with the keyword base registers. Okay. So we know what is register addressing mode. It will be specified by means of some registers. That is what we have seen in the previous example. So what is the register indirect addressing mode? So here also indirectly the operands will be stored in a specified location and it will be moved to the address. Okay. The instruction specifies the register containing the data or operand indirectly by the register. So here the register will be either the base register or an index register. Again coming to the point of base register and index register. And one of the operands is a memory location. Always one operand is a memory location and the other offset is specified by this base index or index register. So if you keenly look into it, one will be the memory location, right, which is fetched from the memory, and other will be the offset provided by this type of base registers. Are you clear now? Yes, the indirect addressing modes where we stopped with the uh, last class. So the instruction specifies the register containing the data or the operand indirectly by the base registers or the index register. So you should remember here one of the register here is the base register or the index register. So example here is move dx comma bl or move al comma bx and move di comma abx. So here if I specify and take the example, let me take the example with the one example which specifies move, yeah, with the destination index. So afterwards I'll come to this last experiment, last example, move dx comma bx. I'm considering this third example and explaining it here. So if the content, if the instruction of the 16 bit is moved to the memory location, and if the DS is specified. So what is DS is the destination, that is a data segment which is nothing but specifying with the 16-bit address location. Okay. And here let DI be. DI, I'm taking the value of 0020 16H, and with the BX I'm taking a content of 2456, which is again a 16 bit. So how this is moved? So you could see here, considering the physical box, So for this 4 bits added with 1 5 bit. So what is your DS? That is actually what is this instruction specifies? This instruction specifies the content of BX, okay, which is moved to the DA. So how is this DA specified? So this DA takes the location of the effective address. So this is the actual effective address, okay, which is shifted, and we can tell this produces the 20-bit physical address. 20-bit physical address is specified where this is considered as a DA. So now taking this as the content where this is our DS. So what is our DS here? It is 5004. So this is the address location where it specifies. And what is our DA? So DA is the nothing but the EA. So if I want to take the effective address, so which is shifted 0020 times. And what will be your physical address then? Just add it. So add this. So it is 0, 4 plus 2, it is 6, 0, 0, 5. So this is the physical address which is actually now created. So you should understand the content specified in this BX. So what is the content specified in BX? That is 2456 will be moved. So this is the location which is generated as a physical address where this will be stored in an 8-bit data only. Okay, this is a physical address. So 50061. So the next address location will be incremented by 1. So it is 50060. Along incrementing with 1 means 50061. So here the first location, that is 56, will be stored here and 24 will be stored here. So this is how the register indirect addressing will be taking place. Are you clear? Yes. Shall I move? Yes or no? Am I audible?
மேம் இன்னொரு தடவை சொல்லுங்க மேம்.
Okay, ma'am. So here, if I'm taking this as an example, move DA, BX, what is this instruction actually specifies? This instruction says the content of BX must be moved to DA. So here you could see the instruction specifies the register containing data or operand which is specified in base register or the index register. So here, which is the index register? They are not directly given the memory location. Am I right? So they have specified in terms of index register. So what is this index register? It is the DA index. So this is considered here as EA, effective address. Always this effective address is taken here, which is shifted one step. Is for 4-bit step location, it moves right or left. Okay. So what happens here means it is moved towards this location. So actually you should specify with respect to here, whereas we are shifting it 0020. This is the doubt you will arise. So this is shifted to left. Very clear? So it becomes 0020. So which performs the operation of rotate left. Okay, ROL. Rotate towards left means what happens? The same data will be recurring. That is, it will occur again. So it becomes 00201D. So look into the blue content which I have written. So this effective address is the address which is taken here or moved towards left. So finally add this with the data segment. So what is this, DS? What is this DS? Actually, we have specified it, right? So what is the DS is nothing but it specifies the location of the starting address. We have seen it. It specifies the starting address where the program starts. So along with that, we have to move the content of what is this instruction says? It says it should move the content of BX to DA register. So this DA is nothing but the index register. So indirectly, this is a register indirect addressing. What happens? It will not move to the specified location. It will move to the 20-bit address location, which is nothing but the physical address. So here in 8086, you should always remember it is moved to the physical address which is created. So how it is created? By means of adding the index registers. We have seen this in the architecture class itself. Am I right? So here what happens? We are adding this and we are finding the only the memory location where it goes, the data where it goes. So the content if content of Bx is given by, second, that is my pen. Yeah, the content of Bx, you could see here, the content of Bx is considered as 2456. Okay, the content is specified as 2456. So we want to find where it goes. So it goes to the physical address of 50060. So you shouldn't specify 50602456. It is splitted into 8 and 8 bit. So the first least significant bit is loaded in first half and the second is loaded in the next. Are you clear now? So 56 first load ஆகுது அப்புறம் 24 load ஆகுது 8 bit எடுத்துக்கு. Are you clear now? This is the
Yes,
data.
ma'am.
Just moving, we are moving the content. Bx register contains 2456. That content is moved to this location. So we want to find which physical address it should move. That is the point here in terms of register indirect addressing. Are you clear now? Yes,
Yes, ma'am.
or no?
Yes, ma'am.
Yes. Shall I move now? Yes. Okay, now coming to the base addressing mode. What is base addressing mode here? Again, it is one more typical one which you should understand. It specifies with the base addressing mode. Here also the same concept. You should find the offset address here. That is, you should find here the effective address first. So what does this effective address means? So in this mode, the effective address is obtained, okay, by adding a displacement, that is a signed 8-bit or an unsigned 16-bit value of Bx or Bp. So the B stands for base indexing. Okay, so base register, it can be Bx. Bx again it can be designated as Bh or Bl, right? And Bp is the pointer, right? So what is DS? Data segment and stack segment registers are also used here. So when we are using Bx, it is used as a base register for data segment. And when considering for a stack segment, BP is used. So X for data. You remember base register for data segment. X specifies, you know what is that X specification. So what is that X? So we have already know what is this BX. It specifies with BHBL, which is an 8-bit register. So here it specifies with the data. So remember it is related with the data in terms of 8-bit. So when coming to the pointer, it is a base pointer, we can see here, it is used as a base register for the stack segment pointer. So where is this stack enabled? So the pointer is used to instruct which is the instruction to be executed next. So remember with respect to the P, that is pointer stack segment. So what is the keyword here? It is a base register, which is nothing but BX or BP. And how we can calculate this? The effective address here is to be calculated. So how is it calculated means it is simply the BX or BP register, whatever is given, which is added with the 8-bit sign. So in the first point itself, it is using a 8-bit or 16-bit value. Okay. So that is added here. So let me go with an example. So here move AX of BP plus 2000H. So this is the memory location. And next is move AL comma BX plus 02H. Now you could see the difference between the stack usage. So you could see here 2000H is nothing but which specifies the address. So if the starting address is 2000, 2001 to it goes on. So what is the pointer does? It points on the stack, which is the next instruction to be executed. So from here itself, you could see it is specified as a memory location. You see 2000H. It is the address location. So here the BP associated with 2000 is nothing but which is specified on a stack content. Please look at the next example. Move AL comma BX plus 02H. What does this indicates? It is nothing but an 8-bit register content. So 02 is specified in terms of 00000010, which is an 8-bit data. So you could see here It is a register which is used as a data segment. If BX is used, you could see this is combined. So BX along with data. If BP, it is with the stack. This with the stack means which is in you could list out with the coins which is arranged in a stack order. Very clear? So now how will you find this address location? So if I consider this example, the second example, move AL of BX0 to H. So for this also we should consider some data. Okay. So considering this BX having the 8-bit signed number. Okay, considering if DS is some location of 5004 16-bit address location, okay, then what will be your effective address? So if I'm specifying DS as 5004H, we want to find the register location and we are taking it a BX as some value of 2000. And what is this 08? 08H is nothing but a 8-bit data. So we are specifying BX in the location of 2000 and DS with location of 5004. So now we want to find the offset. So what is the value of this offset? It is BX or BP. Okay. Here either BX or BP only will be specified. That is added with the 16-bit displacement, whatever is added. So what is your BX here? So BX plus the displacement. Okay. So what is your BX? BX I am considering here as 2000. It is starting address is 2000. That is added with the displacement. What is the displacement here? What is the displacement value? 02. So what will be the location here now? What is your effective address? Solungappa, what will be? Just 2000 plus 02, it is same. It is 2002H. Nothing, because there is no carry or no. So after 2000, if it is incremented by 2, this is 2002. So what is the effective address is? We have found out that it as 2002. And now we have to find out the 20-bit physical address. So what will be your 20-bit physical address? So based on the starting segment, what is your starting segment? 5004. Okay. So remember the box which we have drawn in the last class. So here it is 5004. This is your segment. It is starting segment, and we have to. There is no. They have not given the EA here. In base addressing mode, the EA is not directly given. We have to find it. So we have found out from this offset value, right? And it is nothing but 2002. So it is shifted, so it becomes 2002. Just add this to get the physical address. That is the 20-bit physical address. It is 24025. Are you clear now? 5204. Any doubt? So what is this means? 52042H is it is a 16-bit location which specifies the physical address. So actual address where the content of this to be added. So therefore the content of this AL, right? The physical address is moved to AL. Okay. The content of the memory location. So if I am having in this memory location, if the physical address in the specified, so if I am having 52H, this 52H will be moved to now AL. So in a simple language for your understanding, I am saying, if I am taking the this video, this PPT, okay, this PPT is stored in a F drive, as I have given in an example, F drive store பண்ணிக்கிறேன். ஸோ அந்த எஃப் டிரைவ்ல ஸ்டோர் பண்றது எனக்கு தெரியும். ஸோ அந்த சிஸ்டம் எப்படி நம்ம அது எப்படி கண்டுபிடிக்குதுன்னு தான் நம்ம இதை பார்த்துட்டு இருக்கோம். டீப்பா என்ன பார்க்குறோம்னா உள்ள என்ன நடக்குது, இந்த சிஸ்டம்குள்ள என்ன நடக்குதுன்னா நம்ம அதை செக் பண்றோம். ஸோ அதுக்குள்ள பாத்தீங்கன்னா நான் போய் டைரக்டா போய் எஃப் டிரைவ்ல கிளிக் பண்றேன், பிபிடி பேர் போட்டிருக்கேன், ஓபன் பண்ணிக்கிறேன், ரைட். பட் இங்க பாத்தீங்கன்னா இந்த அட்ரஸ் பிசிக்கல் அட்ரஸ் எங்க இருக்கோ அதை வச்சுதான் இந்த கண்டென்ட் மூவ் ஆகுது. அது எப்படி நடக்குதுன்னா இங்க சொல்லியிருக்கோம். ஸோ எனக்கு வந்து இந்த இடத்துல இந்த கண்டென்ட்ல இருக்கிறது தான் இங்க வேணும். ஓகே, பிசிக்கல் அட்ரஸ் கண்டுபிடிச்சுதான் அதை மூவ் பண்ணணும். ஸோ அதுதான் நான் இந்த பேஸ் அட்ரஸ். வெரி கிளியர் நவ்? ஸோ இன்டெரக்டா சொல்லணும்னா எஃப் டிரைவ்ல நான் வந்து விர்ச்சுவலா பார்த்தா ஓகே எனக்கு தெரியுது இது இங்க இருக்கு அப்படின்னு சொல்லணும். பிசிக்கலா என்ன நடக்குதுன்னா, ஸோ எனக்கு பர்டிகுலரா அந்த எஃப் டிரைவ்ல இந்த லொகேஷன்ல தான் வந்து என்னோட ஃபைல் பிபிடி சேவ் ஆயிருக்கு அப்படின்னு சொல்லணும். So imagine in the system or in a laptop, there are number of memory locations which is used. This memory location starting address 2000, 2001, 2002, 2003. So இப்ப பாருங்க கண்டுபிடிச்சது வந்து 52042. அப்ப 2000ல ஆரம்பிச்சு கவுண்ட் எவ்வளவு வரைக்கும் வருது, 52042 லொகேஷன்ல இருக்கிற கண்டென்ட். ஸோ இதுல தான் நான் வந்து என்னோட பிபிடி வச்சிருக்கேன்னு வச்சுக்கோங்க. அந்த பிபிடி தான் எங்க மூவ் ஆகுது, அக்யூமுலேட்டருக்கு மூவ் ஆகுது அப்படின்னு. அதுதான் அண்டர்ஸ்டாண்டிங். புரிஞ்சுதா இப்போ? புரிஞ்சுச்சா? ஹலோ, புரிஞ்சுதாப்பா?
எஸ் மேம்.
நீங்க யோசிக்கலாம், இதுக்கு அந்த ஜோக் தான் ஞாபகம் வருது. இங்க இருக்கிற மூட்டையை தூக்கி அங்க அந்த இடத்துல வைங்க, அந்த மூட்டையை தூக்கி குடவுன்ல வைங்க, கடைசியில எதுக்குப்பா இந்த மூட்டையை நகர்த்திட்டு அப்படிங்கிற ஒரு ஜோக் வரும்ல, வருமா வராதா? அந்த மாதிரி ஆயிடும். அப்படியா? அப்படி கிடையாது. இது எதுக்குன்னா for joke purpose, remember that you are moving the content to find the exact location where that data is. Are you clear? Yes or no?
Yes ma'am.
Yes. Okay, moving on to next, that is indexed addressing mode. So it is also a simple addressing mode. Let me, இது ஒன்று மட்டும் கொஞ்சம் கஷ்டமா இருக்கும், அதுக்கப்புறம் வெயிட்ஸ். So coming to the indexed addressing mode, what does this indexed addressing mode? So base addressing mode we have seen where it deals with base registers. So here indexed addressing modes means it should deal with indexed registers. That is the only difference. So the operands or offset is the sum of the content of an index register, SI or DI, with an 8-bit or 16-bit displacement. So you could, from the previous explanation, you could see here only the registers are changed. There we used with respect to BX or BP. Here we are using DI or SI with respect to index registers. So it could be an 8-bit data. You could see here 07 is nothing but a simple 8-bit data, whereas D5 is nothing but a 16-bit data. So it could use an 8-bit data or a 16-bit data. And here also we should find the effective address first, that is the offset. Then we could find the physical address. So 20-bit physical address is found after finding the effective address. So for example, if I'm considering the second example, so if I'm considering this, okay, SI plus D5 comma DH. So the program is written like this. Let me take another page. Sorry, I have moved. Once again. Yes. Let me find where I have left the space. Yes. Yes, it is very simple as much as the index addressing mode. Are you clear? Shall I move on to next? Because since this is similar to the previous example, I am moving on to the next. You could see here. Shall I move on?
Yes ma'am.
Yes, base indexed. So base indexed is nothing but, yes, since the previous one is with the indexed addressing mode, now this base indexed addressing mode is nothing but, from the name itself you could say, what is it? It will be combination of base register as well as the index register. So you should hear the keyword you should add with the base as well as index registers. So what is the operands? So operands offset is the sum of the content with respect to the base register. The base register can be a BX or BA, and the index register could be an SI or DI with respect to 8 and 16 bit. So it provides a subroutine to the address of an array allocated based on. So what is the importance of subroutine? You will know when you write a program. So subroutine is nothing but a subprogram which is written in order to execute another instruction and come back to the main program. So if the program is very lengthy or if it is going on execution, so for the purpose of the to minimize the program, we will write a subprogram where the subprogram executes in a short way to provide a loops or anything else, and it could be retained back to the main program. That is what the user subroutine is used. So here in case of base index addressing mode, this is very much useful, provides the subroutine to address easily. So how you could see here, you could see finding an effective address is nothing but you should add the content of the base register as well as with the source index register with an 8-bit or 16-bit number which is specified in the instruction. So example for this is move AX of BX plus SI. So it is the base register. You could see here it is an index register along with the this is an 16-bit content. Whereas here this is the base pointer, the stack pointer along with the content of a 16-bit register. Sorry, it is an 8-bit content. Are you clear? So now with the example, let me explain in finding the 20-bit physical address. So it is also a similarity you could go. So I am writing move alpha of SI with BX comma CL. Okay. So what does this move does? So what does this move does with respect to this? So it has a source index base register along with the CL content. So if I am considering this, right? If BX is specified as 0200H, okay, and SI is specified as 1000H, and my alpha value here is indirectly given as 08H, and my starting address here is 3000H. Finding out the physical address, we have to find the physical address, how it is done. So here we know this is nothing but finding out the effective address from the previous example. It is nothing but adding of the base register along with the index register with the displacement. So what is the displacement here is we have taken. So you could see here if BX is the content given, SA is also given, the starting address is given along with the value of displacement is also given. So you should take this is the displacement. So this is your displacement indirectly known. So what is your BX? BX here is 0200. What is it? It is added with 1000 and again it is added with 8. What is the value here? Simply it is 1208H. Am I right? Simple addition. There is nothing to worry. With respect to zeros, you would simply add as 0 to 100, 1000. It is all done in hexadecimal only, 8021. That is 1208H. Now finding out the physical address. How we will do it? So first bit, with respect to second bit, we are going to write it. So what is our starting address, effective address, and finally your physical address? Can you tell anyone of you can tell me this starting address here is? Anyone? Starting address is? I said it is DS. What is the starting address here? No one is attentive. Please answer me.
Ma'am, 3000, ma'am.
Yeah, 3000. 3000. What is EA now? EA is what we have found. It is 1208. Just shift and write 1208. What will be the physical address now? You should add it. What is it? 8021. It is 31208. Are you clear now? So we have generated the 20-bit physical address. So why it is called 20-bit? Anyone having any doubt on this? Why it is called 20-bit? It is a 4-bit data along with 4. If you add all this, it is a 20-bit data. 16-bit is actually we are using as a address, whereas plus 4-bit is added, so it is a 16-bit plus 4-bit, which is a 20-bit. Are you clear now? Base indexed addressing.
Yes, ma'am.
So the base indexed addressing provides a convenient way for the subroutine programs. Okay. Now moving on to the next. This is very easy. String addressing from the name itself. Yes, next addressing mode will be the string addressing mode. From the name itself, it is directive. It gives the meaning. So the string instruction uses this index register implicitly to access the memory. So you could see here the string instructions is the direct keyword that I can give here. Just you could use the move s. So all those instructions which is having the string addressing or string instructions uses this string addressing mode. Okay. So it will go and implicitly access the memory location where the string is to be moved. Are you clear now? It is a very easy one. Yes, shall I move?
Yes, ma'am.
Yes, come. Okay. Now coming to the I/O port addressing mode, as I have explained earlier, this is nothing but which specifies with the I/O port. The destination of the data or the operand is specified with respect to the I/O port address. So either the direct port addressing with respect to 8-bit port address will be used, or the indirect port addressing where the DX containing DX in the sense we can do it DS, right, containing the port address. So example for this is direct usage of IO instructions, input and output instructions, which carries the instruction set. So in the instructions itself, it will have in AX, the content of 60H will be moved to the AX register, as well as out content where the AL register content will be output. The data will be output, which is indirectly given here, which is moved and taken. Hope you understood. Shall I move on next? We are at the end. ரெண்டே ரெண்டு தான், இதுவும் ஒன்று ரொம்ப ஈஸி. Shall I move கேட்டா எஸ் ஆர் நோ சொல்லுங்க.
Yes, ma'am.
Yes. Now coming to the relative addressing mode, here the destination of the data or operand is specified as the signed 8-bit displacement relative to the program counter. So you could remember relative addressing mode is nothing but which relates to the jump instructions. Right, so always whatever the instructions carrying with the jump instructions are nothing but the relative addressing mode. So in a question paper, if they are asking what does this JNC start addressing mode specifies, you could give it as relative addressing mode. Okay, so example here is jump 8602. So previous instruction, the condition here is there is no condition. The specification should be jumped to. The next instruction must move to the address location of 8602 is the specification. And this is nothing but with the condition. So jump on no carry to the start. So if there is no carry executed from the previous step, then you could go with the start. Else you should proceed to the next instruction. So if carry is equal to 0, what happens? So program counter is loaded with the current program counter content plus the 8-bit signed value of the start location. Otherwise, the executions will be gone as such. That is next instruction. The next last instruction will be the implied addressing mode. So it is the 11th instruction. Sorry, I didn't change. The implied addressing mode is nothing but which gives the instruction using this mode does not have any operand. So you could see here directly it gives the instructions without any operands. So you could see here there is no operands. The instruction. What is the keyword? Those instructions which occurs without any operands specifies the implied addressing mode. So all the machine control instructions comes under this escape, ESC, CLC, complement, CMP, compare with carry, STC, halt, start, everything, right? It all specifies with the implied addressing mode. Are you clear? Are you clear,
Yes,
guys?
ma'am.
Yes. So what is the summary we have studied here? What is the summary of today's class? What is the takeaway of today's class topic? So we have
Types
studied.
of addressing modes.
Very good. What is addressing mode? We have studied. Addressing mode is nothing but in which the way in which the instructions are specified, right? Operands. So what is an operand? Yes, what is an
Data,
operand?
ma'am.
Yes, operand is nothing but the value to be operated. Value to be operated. Okay, how many addressing modes are available in 8086?
11.
Very good. 11 addressing modes are available. Okay. Give example for each addressing modes. Will you give? So in a short duration, it is tedious for you to remember or recall. Let me ask only one question. What is the last in addressing mode we have studied?
Implied addressing mode.
Very good. Implied addressing mode. Example? Implied addressing mode doesn't
TLS, ma'am.
have any operands. Implied addressing mode doesn't have any operands. What is the example you can give?
HLT.
Okay. Halt. That is halt. All the machine control instructions are example for that. Very good. What is the type of microprocessor? So types of microprocessor in the sense, based on the types of microprocessor only the instruction set, that is instruction set will be given. Based on the instruction set only the addressing modes will be given. So you should recollect like that. So where do you use this addressing mode as a programmer? Think like a software engineer. As I have mentioned, I have given an example where I will store my PPT and I will retrieve it. Why I have taken or what is for the easy purpose of myself. That is to ease the way I could access the file. So what is actually happening in the laptop or whatever the gadget you are using, it depends on the physical address only. Are you clear? Why you study this all? Yes or no?
Yes, ma'am.
Yes. So with that understanding, I complete this addressing mode. In next class, okay, before that, any queries from